how to identify whether the given lines are intersecting, coincident or parallel. How can we identify whether the lines are intersecting, coincident or parallel? Okay, so how to identify? So just by looking at the coefficients or comparing the coefficients of the given lines, we can identify whether the lines are coincident, parallel or intersecting. Okay, so suppose we are given two lines, say a pair of equations as a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0, where we have this a1 and b2, a1, b1, c1 are real numbers and they are not 0 simultaneously. Here a2, b2 and c2 are real numbers. a1 square plus b1 square not equal to 0 for this case, the condition, and here a2 square plus b2 square is not equal to 0 for the second expression. Now when we compare the coefficients, we can take the ratios of their corresponding coefficients. So the coefficients of x are here a1 and here it is a2. So when we write down the coefficients, we take the ratios of the coefficients, that is a1 by a2, then we take b1 by b2, then we take c1 by c2. Okay, so in case of if the lines are intersecting, then we can observe that the ratios would be not equal. Which ratios are not equal? So a1 by a2, if a1 by a2 is not equal to b1 by b2, we can see that the lines will be intersecting lines. Okay, if a1 by a2 is not equal to b1 by b2, then the lines are intersecting lines. So means they have a unique solution. If they have a solution, we say that they are a pair of consistent pair of lines. Okay, so we say that it is consistent pair. Okay, we say that the pair is consistent. Okay, if a1 by a2 is not equal to b1 by b2, we can say that they are intersecting lines, or they have a unique solution, or they are a consistent pair of equations. Okay, so a pair of lines have a unique solution if it works the other way around also. A pair of linear equations have a unique solution or have one particular solution if a1 by a2 is not equal to b1 by b2. a1 by a2 is not equal to b1 by b2. Okay, so this is the first case. Now let us take the other case. What happens if a1 by a2 equal to b1 by b2? If a1 by a2 equal to b1 by b2 and it is also equal, these ratios are also equal to say c1 by c2, if the ratios a1 by a2, b1 by b2 and c1 by c2 are all equal, then the lines are coincident lines. Then they are coincident lines. If the lines are coincident, we say that they have infinitely many solutions because they agree at each and every point. Okay, they have infinite solutions. Okay, Again, since they have solutions, we say that they are a consistent pair. Consistent pair. So in both the cases, in both the first case and the second case, the equations are, or the pair of given equations are consistent. Okay, now let us consider this situation where if a1 by a2 is equal to b1 by b2 but not equal to the last ratio c1 by c2, the ratio of the constants, then what happens is, then the lines are parallel. And in this case, since they do not agree at any point, they are parallel, so they do not have any solutions, no solutions, or we say that they are inconsistent pair, inconsistent pair. Okay, it is an inconsistent pair. These two are consistent pairs. Okay, what happens if a1 by a2 is not equal to b1 by b2? The lines are intersecting lines. Let us take some examples to understand this further. Okay, let us consider the equation, the two equations. Say this is say x minus 2y. Let me take the constant 0, 2y plus 0 equal to 0. Okay, or x minus 2y equal to 0, and let me take the other equation as 3x plus 4y minus 20 equal to 0. Okay, in this case what happens is, the see 1 by 3, we can see that 1 by 3 is not equal to minus 2 by 4, because minus 2 by 4 will simplify itself to minus 1 by 2. Okay, so clearly in this case the lines are intersecting lines. So we can directly observe, so this is 1 by 3, this is minus 1 by 2, so they are not equal. So the lines are intersecting lines. Okay, in this case let me take an example for coincident lines. For coincident lines, let me take, say it is 2x plus 3y minus 9 equal to 0, and let me take 4x plus 6y minus 18 equal to 0. Here we can observe that this is 2 by 4, so 2 by 4 is 1 by 2, we can clearly see that this is a1 by a2, that is 1 by 2. So 3 by 6 is also 1 by 2, minus 9 by minus 18 is also 1 by 2. So clearly we can say that in this case, say this is 2 by 4, and then we have 3 by 6 and minus 9 by minus 18, so all of them are clearly equal. Okay, now when they are equal, we can say that in this case we have a1 by a2, we can clearly say that a1 by a2, b1 by b2 and c1 by c2 are all equal, and therefore the lines are coincident lines and they have infinite solutions. Okay, now let us take another example for the parallel case. What happens here? So let me take x plus 2y minus 4 equal to 0. This is one equation, and let me take 2x plus 4y minus 12 equal to 0. Let us take the first ratio. First ratio is 1 by 2. Second ratio is also, it is 2 by 4. And the third ratio is minus 4 by 12. Minus 4 by minus 12. Okay, here we can observe that, see, 1 by 2 and 2 by 4, they are equal. Yes, are they? Yes. So now they are equal to, both of them are equal, and the simplest form is 1 by 2. Now when I simplify minus 4 by minus 12, I get 1 by, this is nothing else but 1 by 3. It is 1 by 3. So when I take, so it is clearly not equal to the third ratio. So the ratio of the first two equal to the ratio, first coefficient, ratio of coefficients of x equal to ratio of coefficients of y, but the ratio of the constants are not equal to the previous set of ratios. So therefore we will say that they are parallel lines, and they have no solutions. Okay, in this case we can even observe that when you multiply the first equation by say 2, you get the second equation. Okay, so that happens only in the case of coincident lines or identical lines. So you can take, or you can take 2 out as common from this line and you get the first line. That is how it is done. Now let us discuss methods of solving a pair of linear equations in two variables. So which are the different methods available to us in solving a pair of linear equations? Okay, let us see. So the methods, different methods available are, the first method is called the graphical method. Graphical method, where we plot the graphs and find the point of intersection on the graph paper itself. In case if they are whether they are, and identify whether the lines are intersecting lines, parallel lines, or or they are coincident lines. Okay, so that we can directly draw the graphs, draw the lines as discussed in the starting of this class, and we can find out the point of intersection if it exists. Okay, so we can find out the solutions of a pair of linear equations using graphical method by plotting the graphs and finding the point of intersections if they intersect. Okay, the second method, or the second set of methods, there are many different methods. They are together called algebraic methods. Algebraic methods. The first method is called the method of substitution, or substitution method. Okay, the second one is called the method of elimination, or elimination method. Elimination method. And the third method is called the method of cross multiplication, or cross multiplication method. It is also known as Cramer's method. Okay, just for your information. So these are the three methods that we are going to discuss: the substitution method, elimination method, and cross multiplication method. So they are all very important. See, the method of elimination would be the most simple way of solving, depending. You just need to observe the equations before solving, and whichever method appears to be easy, we may be using that particular thing. So initially we will be solving some set of problems using each of the methods for study purpose.